Hello again, everybody. This is a tutorial that I have been stressing about computers in automotive, and specifically something called PCMs, ECMs, the powertrain control modules. How important it is to understand how these modules operate and affect the control of your car. Now, regardless of the make of the model, the theories are the same. That's why I don't stress one make or model. If you understand one, you'll understand all of them. PCM needs an input 12 volts. PCM performs or controls the engine performance. So anything of inputs related to engine performance, the PCM has to know. For example, the air, how much air is coming in, mass airflow sensor. The temperature of the air. That's why you have IAT, intake air temperature. Again, how much air is coming in. And is it cold air? Is it warmer air? How much vacuum is in the engine according to load conditions, map sensor, coolant temperature sensor. How hot, how cold is the temperature of the engine, so that it knows to go into open loop, closed loop, oxygen sensors. All these things are inputs. It's information to the PCM, and the PCM has to know in order to control something called pulse width modulation, the duty cycle of a pulse that controls the fuel injectors. Let's start from the beginning. This is a PCM. As you can see, it's a PCM. The dotted line represents that it's part of a PCM. So therefore, we expect to have 12 volts, and we expect to have inputs from sensors. Also, like I said, a PCM can have outputs, controlling outputs. What are outputs? Remember this, regardless of the make or model, the outputs would be motors, outputs would be fuel injectors. For example, when you ground an ignition coil module to create spark, that's the control from the PCM. Controlling on and off time of the fuel injectors to give more fuel or less fuel. That's the outputs of the PCM controlling the outputs. Inputs, like we just said, are sensors. When there's sensors, there are inputs going to the PCM. I can't stress that enough. If you understand that, you'll understand many things. You always have to look and understand for 12 volts. Something has to work with 12 volts, just like your car. So is the case with the PCM, 12 volts. Now, if you look over here, this is the indicator light, check engine light, so to say, right here. That tells you on the dashboard, an instrument panel, it tells you when you have a malfunction or a code. Therefore, as you can see, this bulb also needs 12 volts. Goes through a fuse. Right here. Through a bulb, through this, and the other side goes to malfunction, indicator control. Which is probably a ground, giving it ground or resistive to ground, completing the path for current to flow when there is a malfunction. Let's say that the engine temperature is too hot. The coolant temperature says, okay, no, it's getting too hot, right? The fan is not turning, or the water pump is not turning. So therefore, engine's getting too hot. Check engine light comes on, boom. How much we dread and we hate that check engine light. And I want to again promote my other videos. To subscribe to my channel, Automotive Electronic Schematics by Joseph. Speaking of codes, of engine codes and check engine lights, there are scanner tools that give you the codes, obviously, and it tells you oxygen sensor, coolant temperature sensor, rich or lean, like I just said. Well, these videos give you the definitions, what is considered rich and what is considered lean, and the definitions of the measurements for the codes. Like I said, you do not see it anywhere else except on these videos that I made with the definitions for scanners, regardless of the make and model of that scanner. snap-on, doesn't matter who makes it. The definitions always stay the same. Now, we have this. This is illuminated when we have a trouble code. We need 12 volts, we just said. Here it is, 15 amps, ECM fuse. ECM fuse right here, 15 amps, which is around how much your lights draw when all your lights are on. This is what we need, 12 volts. If I don't have 12 volts over here, because this is not working, guess what? Car doesn't work. You need this controls spark. This controls fuel injection. Besides the pressure you need for propulsion, this electronically controls how much fuel, when to time the spark, when to ground the ignition control module, and when to open the ignition coil to create spark, as I made so many videos about. We have inputs. We need inputs. Like we just said, sensors are inputs. As you can see, I tried to make this simplified as much as I can. It's a little difficult. The arrows going in mean that's an input to the PCM. As you see over here. Mass airflow. This is a type of, if you see the resistor over here, you see this little line going through the middle of it. That means it's a variable resistor. Its resistance is not set a specific resistance. It changes with air. So therefore, the input going into the PCM changes also according to how much air is coming in through the air chamber. More air, more fuel. Less air, less fuel. So is the idea of fuel injection. So once air passes through it, more air comes in, the voltage will change over here. When you put scanner tools, you'll see everything tells you in grams per second how much air and all these things, and it'll give you a good indication of how your mass airflow sensors are changing according to air. The green one that I put over here is just the ground, to make it simpler. All these are connected to ground. The ground wire going from here, from the PCM. Again, mass airflow sensor is an input. When we have a PCM, regardless of the make of the model, I don't care if it's Asian cars, European cars, I don't care what it is, we have to have sensors coming into the PCM to tell us what the present conditions are related to engine performance. Again, this is mass airflow sensor. This is sometimes mass airflow sensor. These are 2 wires over here in this case. Sometimes it's 3 wires, sometimes. A pot like this. Now, air conditioning, AC pressure sensor. To understand how much pressure, I made a video about that. You have low pressure sensor, and you have a high pressure sensor. To turn on the air conditioning unit, the compressor, to be turned on. And with the relay, and I made a lot of videos about that, please see those videos. In shortness or in brief, any sensor, especially this is called a pot, potentiometer. The middle one is called a wiper. And that's what the input is. That's the input going into the computer. The other one, you have to have a B+ line. In this case, it's a 5 volt. Something's going to be 12 volts, but the PCM already is giving us the 5 volts. So we need the 5 volts coming from the PCM itself. We got 12 volts, and now went to 5 volts. There's a little internal resistors that drop the resistors about 7 volts internally and give us 5 volts. We need 5 volts, we need a ground. And what else do we need? That's right, the input to this to tell us the present conditions. So this wiper, the middle one, will alternate. It can alternate up to 5 volts up to ground. So 5 volts to 0 volts, but it can be 2.5 volts, 1.5 volts, whatever the situation is. It's an input telling us by a changing voltage. Same thing over here. Map sensor. We said map sensor is where you have vacuum changes in your cylinders according to obviously according to load conditions. When you open throttle, when you accelerate, you have more vacuum, less vacuum, and these things are all in inputs to the PCM. Again, we need a 5-volt reference to make it happen. We need inputs. As you see these arrows, these are inputs to the PCM telling it how much vacuum. Again, TPS. What is TPS? TPS is next to the air chamber. When you open up, when you step on the gas, you're opening up something called a throttle plate. That allows more air to come in. Therefore, TPS sensor show us how much the TPS, the throttle plate, is opening. That's another input to the PCM. Again, a 5-volt reference. We need 5 volts, and we need a ground established and given to us by the PCM. A coolant temperature sensor. Again, this is, you see this mark over here means it's changing. According to when the engine gets hotter or cooler, that's another input to the PCM. So you see all these arrows that I painted colored in blue. These are inputs. And again, when you look at coolant temperature sensor and you see a coolant temperature sensor, it tells you, if you look at it gives you a code for coolant temperature sensor. But like I said, the video that I made with the definitions of what's acceptable, what's not acceptable for sensors is on scanner tools. You can see those. There's a scanner tool and definitions that you will not find anywhere else to really make you understand what you're looking at. So remember, in shortness and in brief and conclusion, again, we need inputs going into the computer to tell us what's going on. In ambient air, and how much air is going to the air chamber, that's just air. When it goes to the cylinder, you get air mixed with the fuel, obviously. The intake valve opens, lets air in, then we let fuel in, and then we let spark to ignite to cause combustion. You have NOx sensors, you have other sensors, obviously, oxygen sensors, like I just stressed, many more sensors. But the basic idea is, regardless of the make of the model, PCM, ECM, call it what you want, this controls the fuel injectors. I hope you enjoyed this. Please subscribe to my channel of Automotive Electronic Schematics by Joseph. Please leave comments. They're welcome. And I thank you all for watching.